In older homes wired with ungrounded cable, such as older non-metallic cable, relocating a receptacle and adding a new section of cable with a grounding conductor presents a specific challenge. Let's examine the options for handling the grounding conductor in this scenario. Option 1 involves leaving the grounding conductor in place within each box, but tucking it back out of the way, disconnected. This is not recommended because the grounding conductor serves a crucial safety function and should always be connected to something to provide a path for fault current. Option 2 suggests connecting the grounding conductor to the devices at each end and bonding it to the boxes if they are metal. This is the recommended option. Connecting the grounding conductor ensures a low impedance path for fault current to return to the electrical panel, facilitating the operation of overcurrent protection devices like circuit breakers or fuses in the event of a ground fault. This minimizes the risk of electrical shock and fire. Option 3 proposes cutting the grounding conductor off at each end, effectively rendering it unusable. This is also not recommended for the same reasons as option 1. The grounding conductor is intended to provide a safety net in case of a fault, and disconnecting it eliminates this protection. Option 4 suggests connecting a single number 12 American wire gauge THHN green wire and tapping into the grounding conductor of a nearby box, even if it's on a different circuit. This method is not recommended. Grounding conductors must provide a direct path back to the electrical panel. Connecting to a grounding conductor on a different circuit can create unintended current paths and compromise the effectiveness of the grounding system, and potentially cause current to flow on the ground wire, which is dangerous. The best course of action is to connect the grounding conductor of the new cable to the grounding terminals of the receptacles and any metal boxes involved. This ensures that any fault current has the safe and reliable path back to the panel, tripping the breaker and de-energizing the circuit quickly. If the existing wiring doesn't have a grounding conductor extending back to the panel, several options can be considered. Firstly, replacing the ungrounded cable with a new cable that includes a grounding conductor provides the most effective solution. This ensures a continuous grounding path from the receptacle back to the panel. Secondly, installing a ground fault circuit interrupter or GFCI receptacle is another option. While a GFCI receptacle does not provide a grounding path for connected equipment, it does detect ground faults and quickly interrupt the circuit, reducing the risk of electric shock. GFCI protection can be achieved either by replacing the existing receptacle with a GFCI receptacle or by installing a GFCI circuit breaker in the panel to protect the entire circuit. Thirdly, in some cases, it might be permissible to run a separate grounding conductor back to the panel. This method should only be employed if it meets local electrical codes and is installed by a qualified electrician. When working with electrical wiring, always prioritize safety. Turn off the power to the circuit before making any connections. Use appropriate tools and safety equipment, such as insulated gloves and eye protection. If you are not comfortable working with electrical wiring, consult a qualified electrician to perform the work. It is imperative to ensure all connections are secure and properly insulated. Loose connections can create heat and pose a fire hazard. Proper insulation protects against short circuits and electrical shocks. When dealing with metal boxes, ensure they are properly grounded. This can be achieved by connecting the grounding conductor to the box using a grounding screw or clip. Metal boxes that are not properly grounded can become energized in the event of a fault, posing a shock hazard. Carefully inspect the existing wiring for any signs of damage, such as cracked or frayed insulation. Replace any damaged wiring to ensure the safety and reliability of the electrical system. When extending circuits, always use the correct size of wire for the load. Using undersized wire can cause overheating and pose a fire hazard. Refer to the National Electrical Code, NEC, or local electrical codes for guidance on wire sizing. When making connections, use appropriate connectors, such as wire nuts or crimp connectors. Ensure the connectors are properly sized for the wires being connected and that they are securely fastened. Avoid using tape alone to insulate connections, as it can dry out and become ineffective over time. Always follow the manufacturer's instructions when installing electrical devices and equipment. Incorrect installation can lead to malfunctions and safety hazards. When working with electrical panels, be extremely cautious. Panels contain live electrical components that can cause serious injury or death. If you are not qualified to work with electrical panels, consult a qualified electrician. Always test the circuit after making any changes to ensure it is working properly. Use a voltage tester to verify that the circuit is de-energized before working on it and to confirm that the circuit is energized after the work is complete. If you encounter any problems or are unsure about any aspect of the electrical work, consult a qualified electrician. It is always better to be safe than sorry when dealing with electricity. Remember, working with electricity can be dangerous if not done properly. Always take precautions to protect yourself and others from electrical shock and fire hazards. It is also important to stay updated on the latest electrical codes and regulations to ensure that your work is compliant and safe. Consult the National Electrical Code, NEC, or local electrical codes for the most current requirements. In summary, when dealing with older homes wired with an ungrounded cable, the best approach is to connect the grounding conductor of any new cable to the grounding terminals of the receptacles and any metal boxes involved. If a grounding path back to the panel is not readily available, consider replacing the cable, installing a GFCI receptacle or circuit breaker, or running a separate grounding conductor back to the panel. Always prioritize safety and consult a qualified electrician if you have any doubts or concerns. Let's recap the key points. 1. Always connect the grounding conductor to something to provide a path for fault current. 2. Option 2. Connecting the grounding conductor to the devices and bonding to metal boxes is the recommended approach. 3. Avoid options 1, 3 and 4 as they do not provide adequate grounding protection. 4. If no grounding path exists, consider replacing the cable, installing a GFCI, or running a separate grounding conductor. 5. Always prioritize safety and consult a qualified electrician when in doubt. Understanding grounding principles and following proper wiring practices are essential for ensuring the safety and reliability of electrical systems in older homes. By adhering to these guidelines, you can minimize the risk of electrical shock and fire hazards, creating a safer environment for yourself and others. Also remember to check your local county and city codes to be in compliance. Electrical codes are in place to protect people and property. The NEC, or National Electrical Code, is not federal law. It is a standard electrical code written and maintained by the National Fire Protection Association. It provides a comprehensive set of rules and guidelines for electrical installations. States and local governments typically adopt the NEC as the basis for their electrical codes, sometimes with local amendments or modifications. This means that the specific electrical codes that apply in a given area will depend on the laws and regulations of that state and local jurisdiction. To ensure compliance with the relevant electrical codes, it is essential to consult the local building department or a qualified electrician. They can provide information on the specific codes that are in effect in your area and help you understand how they apply to your electrical project. Additionally, keep in mind that electrical codes are subject to change as technology advances and new safety concerns emerge. Therefore, it is important to stay up to date on the latest code revisions to ensure that your electrical work is always in compliance with current standards. A qualified electrician can also help you stay informed about code changes and how they may affect your electrical installations. When working on electrical projects, it is always best to err on the side of caution. If you are unsure about any aspect of the work, consult a qualified electrician. They can provide expert guidance and ensure that the job is done safely and in compliance with all applicable codes. Remember, the safety of yourself and others depends on following proper electrical practices. Ignoring or neglecting electrical codes can have serious consequences, including electrical shock, fire, and property damage. By taking the time to understand and comply with electrical codes, you can help to prevent these hazards and create a safer environment for everyone. Also, remember that local requirements and laws always supersede what is national. For instance, a national code might say something, but the local requirement may be more strict or lenient than what is currently written. Be sure to consult with your local professionals and government to be sure. The use of GFCI protection cannot be understated. GFCI devices are life-saving devices that will disconnect a circuit very quickly when a small amount of current is flowing where it is not supposed to. This is helpful in older homes and new homes alike. GFCI protection is not a replacement for grounding, it is designed to protect people from electrical shock. Grounding is intended to protect equipment and reduce the risk of fire. However, GFCI protection can provide an additional layer of safety in situations where grounding is not possible or practical. Remember to select the right wire size for the electrical load. The ampacity of a wire, which is its current carrying capacity, depends on its size, insulation type, and installation conditions. The National Electrical Code, NEC, specifies the allowable ampacities for different types of wire in various applications. It is important to consult the NEC or a qualified electrician to determine the correct wire size for your specific application. Using undersized wire can cause the wire to overheat, which can damage the insulation and potentially lead to a fire. Over time, this can degrade the wiring insulation, causing a greater risk. Over time, connections can corrode and come loose. This could be the connections at the device itself or the wire connections in the box. Be sure that the boxes are readily accessible so that you can check on them ever so often. If you are unable to access these boxes, then there could be a risk. As a last reminder, please be sure to seek the help of a qualified electrician if you feel like you cannot perform the task safely and correctly.